In this video we're going to look at the cycloid. So we'll start off looking at it in the graphical calculator, and then after we're finished with this we'll go and derive it mathematically. So we've got a circle here. The circle is going to move to the right. As it moves to the right we're going to follow this point here, pxy, as it maps out a locus of points, and that locus of points it maps out is going to be the cycloid. And from the previous video we've seen that the cycloid will give us the path of shortest time between 2 points. So let's go ahead and we'll see this actually moving. So there you see it moving out, and you can see the p of xy mapping out that cycloid. So this graph here is a graph of the cycloid, and if we were to have a ball sitting here and rolling down, then this would be the curve of least time, which is what we were looking for whenever we solved the branchistochrome problem. So you've got access to this little simulation on the resources section, so I suggest you go ahead and you can download that and have a little play with it, and I suggest you maybe have a look and see all of the mathematical equations that generated it. It's not too difficult, it's really just a bit of trigonometry. So let's go ahead and we'll have a look and see how we can derive this using the mathematics. So let's go ahead and we'll derive the parametric equations for a cycloid. We have an xy axis here, we have a circle here, the circle rolls in this direction, and you can see that the centre of the circle is C, the radius of the circle is 1. Now the circle, as it moves round about, if we start at this position here, position D, then as it moves round it maps out this angle phi. So if the radius is 1, then we know that the arc length here is just going to be the radius times the angle phi, assuming that the angle is in radians. So in that case there it's just going to be phi times the value of 1, so it's just going to be phi. So the arc length around this circle is just going to be given by that angle phi in radians. So we can see then also that if this value angle here is alpha, then we can say that this length here is going to be a sine alpha, this length here is going to be cos alpha, and this point here, p of xy, is a point on the circumference of the circle. So we're interested in the x value and the y value of p. So let's go ahead and we'll derive the x value first of all. So we'll call that p of x. Now we can see here that this value sine alpha, well, that sine alpha is just going to be that distance BD divided by the radius r. Now the radius r is just 1, so it's just going to be BD upon 1, so it's just BD. So sine alpha is this length BD. Now also you can use the trig identity. Sine of 180 minus alpha will give us the angle sine of phi. So again, that's just a trig identity, you can go and check that up. So we're interested in the distance to point x. Now the distance to point x is OB. But that OB is just going to be the distance OD minus BD. Now we know the distance OD, that's just the distance it's travelled round about, which is just going to be the arc length, which is just going to be the angle phi. And the distance BD we just found out is sine of phi. So we can therefore say that the value p of x is going to be, well, we're assuming here that the radius is just a value of 1, but the radius could be any value. So we could take the phi minus sine phi and multiply it by some constant there. It would just represent a circle of any radius. So we could say then therefore that the point p of x is going to equal b phi minus sine of phi. So let's move on, we'll look at the py. So the vertical height given by py is this height here, which is just going to be our dc plus our cr. Now we know our dc is just the radius of the circle, which is 1, and we know that our cr is just our cos of the angle alpha. Remember, we want it in terms of this angle phi, because this angle phi is the starting point, and that's the angle that maps out the actual arc length. So we can therefore say from the trig identity, cos 180 minus alpha is equal to, that will be minus cos of the angle phi. Again, just another trig identity. So therefore we can say that p of y would equal 1, and it would be, in this case, minus cos phi. And of course, if the radius was not an angle, or not a value of 1, but some arbitrary value, say you call b, then we can say that p at y is going to equal b times 1 minus cos of phi. So that's us derived our parametric equations for our cycloid. So our p at x is equal b phi minus sine phi, and p at y is b1 minus cos of phi. So that's all there is for this video. I'll get you on the next video. Goodbye.